So our next two definitions are going to be polynomial functions and your rational functions, okay? So remember, students, polynomial functions, when you guys were studying in Algebra 2 Trig, these curves are going to be smooth and continuous, okay? Now, rational functions, these guys over here, they have asymptotes, okay? That means it's not continuous, right? All right, so the general form for the polynomial, as you guys remember, it's f of x equals, we have a leading coefficient, let's call it a subscript n times x, and then to the nth power, let's say 5x to the 11th, okay? Then we have another leading coefficient, let's call it a subscript n minus 1 times x. Now, if the first term is 11th power, then the power of the second is 1 less. So that's what we're going to say, n minus 1. And we are going to have the third and the fourth and so on and so on. Then we're going to have a sub 1, okay, second to the last term here. We are, as you can see, I'm not writing any power, so that power is going to be a 1. And then our last term is a subscript 0. As you can see, there's no x variable because a sub 0 will be a constant. Now, because polynomials are going to be smooth and continuous, to find the limit, students, as x approaches whatever c value we want of our function here, f of x, it's like finding algebra 1 value. All we have to do is plug in c4 for the f function. Because again, based on our definition, okay, if the function is continuous, then it's like algebra 1 when we're looking for the limit. Now, rational functions in the form of a fraction, hence ratio in the word rational itself. So on the numerator, we have p of x divided by q of x, okay, where p of x and q of x, students, are polynomials. And in addition, because it's a rational function, your denominator, q of x, can never ever be 0, okay? R of x, which is your rational function, is usually not connected at q of x. Okay, and set it equals to 0, because that's either a whole or an asymptote. Now, to find the limit of this, okay, since we know this is going to be some sort of a discontinuity, some sort of a asymptote or a whole, we can't just say that we can just go straight and use algebra 1 to find the limit. So let's go do example 3. Can you guys see that example 3 says, we have two examples. Determines the limit for both. A says, find the limit. How we read this is find the limit as x approaches. If you can't see this, guys, this is x approaches negative 1 divided by 2 of this function, 3x squared times the quantity of 2x minus 1. If you distribute this, it's going to be a polynomial, but you really don't have to distribute. We don't have any fraction, therefore we know it's going to be continuous the entire time. So since it is continuous the entire time, all we have to do is plug in negative 1/2 every time we see an x. So that means a 3, we're going to drop that down, we see an x squared, so that gets negative 1/2 squared. Then we have 2 times negative 1/2 here, minus 1. And then we are just going to follow PEMDAS, okay? So 3 times negative 1/2 squared is going to be a quarter. Negative half times 2 is negative 1 minus 1. 3/4 students times the negative 2 is what we are looking at. And this will allow us to reduce, and it's going to be negative 3 over 2. So the limit as x approaches negative 2 of this whole function is negative 3 over 2. What does that really mean? It means the y value is negative 1.5, negative 3 over 2, when the location of x is at negative 1. Now let's go do B. Now, as you can see here, B, we can try to plug in -2, okay? So let's read it first. Find the limit as y approaches -2 of this function, y squared plus 5y plus 6 divided by y plus 2. So what if we forget and we're gonna plug in -2 every time we see the y? Okay, so let's try. -2 squared plus 5 times -2 plus 6 all over -2 plus 2. Well, -2 plus 2, students, this is 0. We can't have a 0 in the denominator, so that's not going to help us out at all because we can't divide by 0. So what we are going to do, since substitution did not work, is we will factor this out. Okay, on the numerator, y squared plus 5y plus 6, when we factor this out, we will have a y plus 3 times y plus 2 divided by y plus 2. Well, in math, we can definitely reduce. That will allow us to simplify this fraction down to y plus 3. Okay, now we can substitute this in. So when we substitute this in, we only have one y left. So -2 plus 3 equals 1. So the limit as y approaches -2, students, of this function, it's approaching 1. Okay, again, I'm using the word approaching 1. Excuse me. So let's write down the tactics for finding our limits, okay? Tactics for finding limits. Number 1, always try to see if you can find the limit by substitution, because that's the easiest. What happened when substitution does not work like B? Then try to see, students, if you can factor and cancel, and then substitute again. All right, so write those steps out.